Okay, students, how are you all? Okay, today is our last, I would say the last part of our lesson in chapter 2, okay, which is going to be our part 8. So I hope to complete today's lesson. Okay, there are three things we are going to learn in today's lesson. That is number 1, what is the meaning of power rating? Number 2, how to calculate electrical energy usage. Although you already learned about electrical energy and power in the last class, but how we are going to calculate those energy and power in home appliances. You know, I think I told you in the last class, we have been using a lot of electrical appliances in the houses. So we need to know how to calculate the energy and also a little bit of calculating the bill, how the Tenaga Nasional, the TNB is calculating the bill for that. And then the last part is of course efficiency of electrical appliances. You know, we have been using all the electrical appliances. The energy that we are giving is not actually the energy that is given out. Okay, we'll see that in detail. Okay, so before I start for today's lesson, in the last class I asked you to do some work, okay, on the energy and power. So please take note, the answers for question 3, 4 and 5 I've already given here. Okay, you're supposed to get these answers. And then I'm just going to discuss question 2 only as in the second example about the solution. Okay, so I want you to take note and please try the rest of the question which you should have done by now. Okay, after this lesson I'll be giving you a complete overall exercise about this, which I told you also about this entire chapter. There will be some structure questions, maybe some essay questions, and also objective questions, which is going to cover the entire revision of this chapter, electricity. Okay, so please try all those questions. I'll give you a couple of days. After that, I will come back to you to discuss the question that you don't know. So I hope by now you can log on to your Google Classroom, and then through your monitor or what, if you can't put in the questions that you are not sure, you can ask your monitor to post to me through Telegram. So in the next class, I only discuss about the questions that you don't know. Alright? Okay. So let us look at page 58. Our lessons today on page 57 and 58. So the question on page 58, question 2, is given there. Okay, what is the meaning of power rating? Okay, power rating, you already can see at page 57. Any electrical appliances, if you look at the label, let's say for example, if you take a calculator, alright, if you take this calculator, it also given the power rating over here. Okay, that means it will give you two quantities. The voltage that the appliances need to operate and also how much power it is consuming. Usually two units are given for the, two quantities are given for the any electrical appliances. Number 1, they give you the voltage. Number 2, they give you the power consumption. Okay, like for example, if you look at page 57, power rating on top here is given. So you got to, in SPM, it's very common question they ask, what is the meaning of power rating? Okay, but with of course with an example, right? They give you like here, electrical kettle which marked 240 volt, 5500 watt means, what does it mean? Okay, electrical kettle labeled 240 volt and 1500 watt. What does it mean? Okay, what does it mean? What is this power rating means? It means, it's written here as you can see, the electrical kettle consume 1500 joule per second. Okay, because this is joule per second, watt. So the electrical kettle consumes 1500 joule for every 1 second if it is connected to 240 volt. That means if you don't connect to 240 volt, won't give you this energy. Let's say you take an example, a small bulb. We supposed to use 2 battery for the bulb to light up normal brightness. Let's say you are using only 1 battery. That means you're, instead of using 3 volt, you're only using 1 battery, 1.5 volts. So the bulb won't give you the normal brightness. You know something wrong, the bulb is a bit dim. Okay. That means it's not operating at the power rating of that device. Okay, that's the meaning. So any electrical appliances always come with this. So in this question 2, it is asked, the immersion heater has a power rating of 240 volt, 750 watt. What is the meaning of this power rating? It means, we can say the immersion heater, alright, will consume 700 and okay, it's 240 volt, 750 watt. That means the immersion heater will consume 750 joule per second if it is connected to 240 volt. That's how you answer. Or you also can say the electrical immersion heater consumes 750 watt of power if it is connected to 240 volt. Okay, so that's how you answer. So any electrical appliances given, you just go first, you mention about how much power or energy per second is used, and then followed by how much voltage is connected to. That's the meaning of power rating. Okay, now let us look at the solution. The second part of the question they asked. Okay, this question given 250 volt, 750 watt. That's the power rating. Okay, what is the resistance? So resistance, as you can see here, they are given power and volt. Power and volt. So we can use this equation. R is going to be V squared over P, that is 240 volt square divided by 750 watt, which will give you 76.8 ohm. Okay, so that's how you solve for question 2B. 2C, they ask what is the electrical energy consumed in 15 minutes. So energy consumed in 15 minutes, you can use energy since you know resistance and volt, so and also the time. Time given 10 minutes. Time given 10 minutes. So you can use V squared over RT, which means V squared 240 square over R, you just found out 76.8 times T, 10 minutes, 10 times 60. Okay, so if you work out, you should get 675,000 of joule. Okay, this is one way of doing, because since you know the voltage and time and also the resistance. Okay, resistance you just found. But there's another simple way of doing. Energy, we know that power is energy divided time. So therefore, energy is power times by time. Okay, so energy times power times by time. So what is the power? 760 watt, 50 watt. Time 10 times 60 in seconds. So you will get the same answer, 675,000 joules. So we can do it. In fact, this solution is preferred because it's quite easy. Power times by time we get energy. Otherwise, you're going to use the voltage resistance or current resistance equations to solve the problem. Okay. So for question 3, 4, and 5, I want you to look at the solutions over here. Of course, 5 I've given as 12%. This one I'll discuss. This is about efficiency. Alright, so these are answers. So please take note. I'm going to erase and you can retrieve later. Okay. So okay, now let us see. They are asking how to calculate electrical energy usage at home. Okay, electrical energy, usually for calculating house usage electrical energy, we use a very simple equation. Energy is power times by time. Okay, this is what we use because power is always written in the electrical appliances based on the power rating and how long you turn it on, how long you use it. Okay, so the power usually we don't use watt, here time or per second. This is SI unit. But for home appliances, we always like to use power in kilowatt and time in hour. So energy here is, this is the unit that we use. Kilowatt hour, no more joules, because joules is going to be very huge energy in terms of values. So if you use kilowatt hour, it's going to be very simple. And usually 1 kilowatt hour is written as 1 unit. 1 kilowatt hour is known as 1. So kilowatt hour, don't be mistaken for power. It is energy. Power times by time. If it is only kilowatt, it is power. You multiply by time, you will get energy. Okay, so 1 unit, 1 kilowatt hour. That means, let's say you are using an electrical kettle or you use aircon. It is 1 kilowatt power rating. You turn it on for 1 hour. How long you are going to use? How much energy you are going to consume? Very simple, 1 kilowatt times 1 hour. So you use 1 kilowatt hour. This is actually how many joules. Let's say you want to calculate in joule. So for joule you have to use the power in watt. So 1 kilowatt is 1000 watt. 1 hour is 60 minutes, every minute 60 seconds. So you get 360, alright, 60 times 60, this is 36, and then, so it is 3.6 million joules, you know, that is 3.6 times 10 to the power 36 joules. So this is actually equal to 1 kilowatt hour. So we don't use this joule unit because remember you are only using 1 kilowatt hour of one aircon turn on for 1 hour. In a house you are using so many electrical appliances. So if you want to count in joules, it is not practical to for billing purpose. So for billing purpose, you always turn it into kilowatt hour. So if you look at your page 57, they give you a table there, right? How to calculate energy consumption for a house. Okay, that's a simple. I'll give you a model there. So please refer there. Okay. So here they give you, I put it very simple, fan. The power rating is, power rating of fan is 50 watt in watt. Then television is 100 watt. Computer 200 watt. Aircon 1000 watt. Washing machine 1800 watt. Water heater 3600 watt. Okay, so and the time, so usually what we do whenever you ask you to find power rating for house, energy consumption for house, we don't use watt anymore. You have to use it in kilowatt. I already told you. Energy we use power times time. Power must be in kilowatt, time must be in hour. So 50 watt it changed to kilowatt. 50 divided by 1000, so you get 0.05 kilowatt. 100 0.1, 200 0.2, 1000 in 1 kilowatt, 1008 1.8, 3006 3.8. So all these in kilowatt. So the next is time given here. Okay, time they already give you in hour. Okay, time given already in hours, so it's very easy. 1 hour, here 1 hour, you turn on for 1 hour. This also you turn on for 1 hour. Washing machine half an hour, and electrical heater half an hour. So very easy now. Kilowatt hour is the energy. You are using energy. So 0.05 times 1. This is 0.1. This is 0.2. This is 1. 1.8 is 0.9, 3.6 half is 1.8. So this is in kilowatt hour already. So the total energy you use 5, 10, 12, 20, 2, 3 and 4. Okay, so please check this. Alright, 2, 3, 3.9, 4, 4.05. So this is the kilowatt hour you are using in for hour. Alright, this energy, this is actually the energy, and kilowatt hour in energy. So if you want it to know in how much kilowatt, this is kilowatt hour. So if you want in joules, kilowatt you change it to watt, you times by 1000, then hour you change to 3600. This hour in 1 hour actually. So this is the energy you are going to get in joules. So which is going to be a very huge value. But for TNB, they use 4.05, and maybe this is for 1 day. If you are using the same manner for 1 month, let's say April, then you multiply by 30. Let's say you are using for January 31 days, so you times by 31 days. So this is how you calculate energy for home appliances. Okay, and then they give you the rating like how much. Okay, maybe 1 unit of energy is 25 cents. 1 unit means 1 kilowatt hour, 25 cents. So here 4.05. So 4.05, 1 unit, that means 1 kilowatt hour is 25 cents. So you just times by 25 cents. Then you get how much you have to pay for the usage of that energy. Okay, so that's how you do it. It's also given an example at page 57 at very bottom. They'll give you one example so you can refer that. Okay, and finally we go into the efficiency. So remember, for any electrical appliances, you are given always in watt, sometimes in kilowatt, but you must change it to kilowatt. That time, if they give you 30 minutes, it must be half an hour. So you must change the time into hour. You cannot use minutes unless you want to find in non-SI units. Okay. And finally, efficiency. Okay, efficiency is simple. Okay, let's say a bulb. Here I've given you as an example. You can refer at page 58. Efficiency given as power output. Okay, power output divided by power input times 100%, or you also can calculate efficiency in energy output divided by energy input times 100%. Okay, so you can use either one, depend what they give you. Like they give you in power, in terms of power, then you use either one. Okay, both are can find the efficiency. What is the meaning of efficiency? Efficiency means how much the bulb is rated. That means how much the bulb is consuming and how much useful energy is given out. So here the output is actually useful power. What is the meaning of useful power? Okay, suppose a bulb like the fluorescent light given as 40 watt. 40 watt is the labeling written there, that is the input. So any power rating comes, the power written there is actually the input. Okay, so bulb, the useful energy is what is given out. If the bulb consuming 40 watt, but the light is only giving out only 20 watt, that means another 20 watt is wasted in the form of heat. That's not used energy. Okay, so useful energy is light for the bulb. So it's only 20 out of 40 is giving out as light. So therefore 20 over 40, this is energy given out in light, this is energy consumed by the bulb. So it times by 100%. So you only get the bulb work only as 50% efficiency. So the other 50% is not efficient, that means it's wasted in the form of heat energy. So for radio, if you take for example, also it comes in the form of heat. Okay, so the useful energy is only the sound energy that is given out. Okay, so this is how you calculate the efficiency. So you can look at the examples given. Alright. So based on that, you can work out question 5 and 6 given here. Right? What is the useful energy and what is the given in energy? Okay. Alright. So maybe I give you one example, a simple example. Okay. This is quite common question you can see in SPM also. Okay. Suppose there is a crane. Okay, there is a crane. What is the use of crane? Crane can lift any object. Alright. So let's say this crane is lifting this object is maybe 500 kilogram of wood, is lifting it up, or let's say is lifting it up for 2 meters. So it lift it up in 2 meters in, let's say, in 5 seconds. It lift in 5 seconds. So the one is lifting it, the engine of the crane. So the engine of the crane uses energy, okay, or power. The power given to the energy, to the crane by burning the fuel and all that. Let's say is given in 20,000 watt. That's the power the crane is consuming. Okay, what this is called the input. The power output, how much work this crane doing over the time. That means power output is energy output divided by time given. In other words, power is energy divide time. Okay, how much energy this work? That means energy here means what is the output work the crane doing. The output work here is actually gain in potential energy. Okay, so the potential energy the crane gain is mgh. I hope you remember chapter 2. Okay, so the energy here is 500 kilogram. G, you know, standard value 10 gravity. The height is 2 meter. Okay, so here 1000 times 10 is 10,000. Okay, so this is the power output. The crane is doing the job, but the crane is taking in 20,000 watt. It's only doing 1000 watt here. Okay, so although here they give you time, right? Okay, here sorry, this is joule, joule. So you want power, yeah, energy divided by time. So this energy 1000 joule, 10,000 joule divided by time 5 seconds. So you can get 2000 watt only. That means the power of the crane to lift this 500 kilogram for the height of 2 meter in 5 seconds, energy divided time. The power is energy the given up divided by time. So energy mgh divided by time t. Okay, energy divided time. So you can get 2000 watt only the crane is giving out. Okay, but it is consuming 20,000 watt. So therefore the efficiency of the crane is 2000 over 20,000. Okay, times 100%. This is given. This is given. These all are given. So you only can get 10% efficiency. That means the crane only working at 10% efficiency. This is quite common, you know, in any machinery, any electrical appliances. If you can get 50%, 60%, that means it's very good already. Okay, most of the time it's always below 50%. So here the crane is only working at 10% of efficiency. That means 90% of the power is wasted in the form of heat and sound. You can see that when the crane work, you get a lot of sound. Then you saw there's a lot of heat there. So 90% is wasted in that form. It's only giving you 10% output. So this is how you do the calculation. So you please refer at page 59 for that. Alright, and then they also give you how to increase the efficiency of any electrical appliances. So this one is just for you to read up. Please understand how you can save energy, yeah? By cleaning the fan, doing servicing and all that. All those things they have already explained over here. So you please go through that on your own. I won't go through with you. So to conclude, these are the things that we have covered today with the examples. And I've given you the questions, and I'm going to give you more questions. The one revision question for the chapter 2, as I told you at the beginning of the lesson. So please try out all the questions. I maybe give you for maybe another 3 to 4 days. Or maybe today is Tuesday, so by Friday or Saturday, I'll get back to you for whatever question. The question will be uploaded in 1 or 2 days time. So please try all those questions as a revision for this entire chapter. So after which, the following week, maybe I will go into magnetism, the 3rd chapter, which I won't come back to this when the school reopens after the COVID holidays. So you won't come back to this unless you have any issues to discuss, which I've been repeatedly telling. So please, I hope some sincerity in you to follow my lessons. So I'm doing it fast because this is a video clip. You can always retrieve again and again, slowly you can go through whatever I'm talking and giving you the examples. So please go through everything in detail and do it to your very best. Alright? So discussions, once you feedback to me, I'll discuss any questions that you don't know from the homework given. Okay? So with that, I end today, and for those Indians, I think today is Tamil New Year, so wishing you a happy very New Year. And of course we are going through some hard time. It's global, it's called pandemic. So if you look at the history, it happens every 100 years once. Alright, during the 1920, they have a Spanish flu. Almost 100 million people died. Okay, so now with the modern technology, we are doing all the best. So we have already minimized the fatality among human beings. So please take care of yourself. Don't go out. Okay, and you've been listening. You turn on the radio, TV. You've been listening all about the hygienic. Okay, washing your hand, face. Okay, keep a distance from people. All that in the public place. exercises. So please take care of yourself. Health is very important. Okay, with the health only we can make our life very meaningful. Okay, so with that I end the lesson today. So wish you all the best. Please try. So I won't be coming in the clip for another 4 or 5 days. So please try all the questions. Then we will see you soon and time to come. All the best. Thank you very much.